Thanks to you all for being here and giving your most valuable asset, which is your time. And so I appreciate that. Also for at least adopting me just for the period of this talk, since I'm not an aviation expert. I just want to put that out there. I know you all are the aviation experts, and I like to start by thanking you all for what you do, because what you do is important. And I hope that if I achieve anything today is that you see yourself in some of what I'm going to talk about, particularly from a futuristic perspective in terms of how I'm seeing things and various pieces of technology and so on and what that means. So I'm just going to shift over to my slides, and I really want to think about aviation's horizon. It really is about human ingenuity accelerated by digital transformation. Now, ultimately, when I fly on planes, they're hardware. They're going to take me from point A to point B if I'm in a commercial space, or if I'm supporting my defense customers. We need to make sure our war fighters or our satellite operators, if they're Space Force or whatever, all still live in the all-important hardware world. We live in a physical world, and so that is ultimately where all the arrows go. But what I'm interested in this morning to talk about is in the middle, is how do you get from idea and concept into those things. And so I just want to try and say that at the top, because I'm going to have what appears to be a digital and software heavy approach, but I want to say that's a mistake. It really is the proper fusion of hardware and software, and the two don't need to be at odds with one another. I am coming to you because I am, as Linda mentioned, with PricewaterhouseCoopers, which is a Big Four accounting firm. It's best known for that. And so you might be wondering, like, why is an accounting firm at the aviation community? And the reason is because we as a firm have been doing aerospace and defense for decades. And more than just doing the accounting, the auditing of financials and so on, we do still do that. That has been our core mission and has been for almost 2 centuries of our existence. Our brand is trust. But we also have an extremely, exquisitely good, talented team that support this community in general in all of these various areas. I won't read them, but just to say it covers everything in commercial and defense, just in order to help that client succeed in whatever they're doing. So you might not see us in various things, but I wanted to explain why. But it also informs my business proposition for why I'm a partner at the firm, and I'm very excited. I'm going to start by just referencing, I would say, a skill that I developed, I would say, in my mid-career. I had landed at the Government Accountability Office as the chief scientist there, which meant I was supporting the Congress in oversight into every potential science and technical type program or project and so on around the US government. So I'm saying that because one of the hardest parts wasn't doing a retrospective look at a program or a project. It was really looking forward and saying, what does this mean? Because if anything, the members of Congress wanted to know is like, so what do these things mean? Such and so technical event would happen, or some kind of technical revolution would start. And we're in one now, as you all know, with respect to generative AI. But they always wanted to know why, or what could I expect? And so I learned or made the acquaintance of a futurist, a gentleman by the name of Brian David Johnson, who was previously the foresight officer, the chief foresight officer at the Intel Corporation. And that's because the product cycles in Intel, if you understand the semiconductor or chip business, are like 7 to 10 years. And so by the time you start building something, and then by the time something comes out in hardware on the other end, it's an extraordinarily long product cycle time. But it also almost reminds me of aviation, by the way, right? So the whole issue is how to get on speed. But the point with him was he used to have to convey to his leadership, to convey what he calls a science fiction prototype, right? It means telling a story, which is not necessarily about trying to predict the future, but trying to imagine the future and then pull in science fact into that story, making various cameos along the way. So I'm saying that because what I'm about to show you is a science fiction prototype, and I'm going to ask particularly this audience, who are way smart on all kinds of aviation issues to squint just a little bit, technically speaking, because I'm sure there'll be some things that might make you say, yeah, that'll never happen, or that's not the way the laws of physics operate in that scenario. I tried my best, but my point is to show you what I was trying to imagine in terms of the future of aviation 2050. And so it would look something like this. Imagine living vertically. It means that you could be in a dense urban center and you're living more at the top. You might never, because you have the ride app type ride sharing entities are taking you around, but not on the surface street the way you're used to. They're taking you around in your eVTOLs. And so our traveler, you, are waking up this morning in your pre-made breakfast. You have your nutrients laid out just for you, your clothes. You have a robotic valet, and it's considering what are you doing in terms of your client type and so on. But your screening is really pushed out to the edge. This is the future of TSA, pushing you into where you are, where you live. You're stepping into your millimeter wave scanner at TSA installed in the hotel, because then you're going to be mag-lifted to the roof, and it's going to load you into your eVTOL through the vertiport. And I know that this image is not too science fiction-y, because we already have these things now. And so that's what's cool, is the idea of the future's already now, and so a lot of this is putting these things together. What would it mean? So you load onto your eVTOL, and you are sitting in your custom crafted coffee. You ordered a ride by yourself. You didn't want a ride share on this particular thing. But the important part is no pilots are needed, and you're going to be operating, because in this scenario you live in Manhattan, and you are going to be part of your aircraft will be inserted into New York City's urban flight management system, which is fully integrated, autonomous flight management system. And that's important because, and by the way, just pausing, when you are taking off, you look out and you notice that you see these things that are essentially laser weaponry, directed energy, that is there to mounted on top of, and this was a result of the 2025 Golden Dome Initiative to shoot down missile defense. This is your homeland and national defense type spend on this. But this technology, you notice the mounted system is designed for short range. You're talking about dazzling damage, destroying incoming threats like drones, mortars, and missiles. And of course, drone warfare has already reshaped battle philosophy, orders of battle, and so on nationally. So the system has been installed and updated based upon that information. But one shot is $10. It's not a kinetic shot. It's the directed energy, so you're going lower cost to be able to do that. It's been tested against drones and metal targets at high accuracy, like to a quarter at over 2 miles, like hitting a target the size of the quarter. Okay? And then now when you're still running around in your taxi on your way, you're seeing all of these things, these drones. Grubhub are delivering drones, Amazon, Walmart, all of the drone delivery services are there, but all of them are being integrated and managed in dense airspace by an autonomous system with this is the New York urban system, is being managed by one operator in this case. So what happens is you land at JFK, you notice the modular battery is being swapped out in real time as the aircraft lands. You swap it out, it completes before you even get to the vertiport exit, and you've already been pre-cleared through security because that's already happened, and now you're at your departure aircraft on the ground. Your bag, in the meantime, the Apple AirTag type technology has been integrated into your luggage, and so what's happening is it's already tagged to you, authenticated to you, and then it's been put on the carousel. There's no baggage lines, there's no checking a bag. Everything has been autonomously operated and then tagged to you through data and the analytics. The data handling communications allows the crew to prepare the aircraft and start the flight plans immediately, and reducing the gate waiting time. Okay, so And what's also happened is, as you think about aircraft of the future, you might take or adapt Navy launch systems to help aircraft get launched more quickly, to get up to speed more quickly, to lower the amount of fuel burn, and so on, to get up to altitude. Your plane reaches about half Mach 0.5 as it leaves the runway, and at altitude the ramjet ignites, accelerating the plane. And what you ask during your flight is your digital concierge to tell you about your aircraft, and it tells you have transitory engines. It's that type. From 0 to M2, it's ramjets, M2 to M5, or I'm sorry, 0 to M2 is turbines, M2 to M5 ramjets, and then scramjets for M5 plus. The flight is, your aircraft looks like this, and you'll notice that there's no cockpit. That's because there's no pilot in this scenario. It's a first class only type aircraft on this, but it has the delta wing shape of the vehicle to allow it to be the primary lift above Mach 5, and the wings provide the lift at the other or lower speeds. The surface is a tantalum hafnium carbide, and a leading edge composites are zirconium diboride or hafnium diboride, in other words, to help the heat transfer and to avoid delamination of the vehicle. The titanium airframe this is grade 5 titanium. There are other composite alloys on the way, but this is all for strength, weight, cost, and manufacturability. And then you're autonomously being tracked through space-based radar to make sure that collisions are avoided and any threats are identified and neutralized. Your in-flight is an incredible first-class experience. You have adaptive privacy pod with electrochromatic smart glass walls that switch from transparent to opaque. You have noise-canceling canopies. You have sensory control mechanisms. And your seat sensor monitors your heart rate, posture, sleep cycle, and even the lighting adjusts to your circadian rhythm so that when you arrive, you're refreshed, ready for business to where you're going to go. Your AI concierge that you were chatting with earlier is on your left-hand side, and it's supporting these holographic displays, AR, and so on, and even this digital portal that uses depth of field and makes it look like it's a conventional portal, but it's really, you're not looking out the window, you're seeing a digital rendering of what is going by on the window. And so lastly, because it's finally airline food has got there, we have Michelin star eating on the plane, and you ask your concierge to do that. Now, what also is newer is the fact that you have cloud on orbit. We're all familiar with Starlink and with Amazon Kuiper, but what's happened by this time is you have cloud infrastructure, cloud computing has been put up onto low Earth orbit. You have interconnected systems through high data rate laser beams, approximately 10 terabits per second on this. And the compute power on this for each satellite is at the 10 to the 24 floating points, or YATA flops. By the way, we're starting to run out of Greek prefixes from kilo, mega, giga, tera, etc. We're at YATA. So that's, for those of you unfamiliar with the nomenclature, this is a 1 with 24 zeros after it. So it's a phenomenal amount of computing with respect to what's gone on. And it's a result of the exascale and Zeta-scale computing programs led by Department of Energy, Department of Defense. But the cooling systems are radiative. These are using all the next gen of graphics processing units and so on, and the power supply is there where it's able to be supplied by these advanced solar panels. At the same time, your flight is also being tracked by the US Space Force using the air moving target indicator capability and a tracking layer to be able to understand what's a commercial glide vehicle versus what's a threat potentially. And so your space-based radar is guiding your autonomous pilot into New Maputo, which is in Mozambique, using your aerodynamic control surfaces only with no thrust. And the timing it took from you to get from your vertiport at JFK to landing in Mozambique was 3 hours, and you check your watch to make sure you could be home for a late dinner. But what brings you there is that you're actually an investment partner, and what you're doing is working on due diligence on a titanium mine in Mozambique, and that mine itself has been part of the story of dropping the cost of titanium to less than $2 per kilogram, which is on par with high-grade aluminum. So now you have very strong, lightweight, and you're seeing incredible capabilities being brought on that have long been wanted with titanium for advanced airframes. But this is what you're there to do in terms of looking at this particular investment, and the mine itself is already operating in a way where things are connected together, optimizations are going on, and you have what really amounts to a circular economy in mining. Okay, so that's the storyline on this, and I just want to pause and say it's an interesting story, hopefully, somewhat. Again, is somewhat how plausible some of those things are is up to your judgment. And again, I think this is where what I was trying to do is stitch together a lot of components in terms of commercial, defense, aviation, as well as enabling technologies and things, materials science particularly, that are part of that. But the question is, how might we convert the science fiction into science fact? We had facts and things in there. And this is where I'll shift to another story personally, that while I was at GAO, I had a friend of mine become the chief scientist of the US Air Force. And I remember having lunch with him one day, and GAO was, at that time, when I was there, was under a mandate from Congress to have an annual look, in this case, at what was the most expensive weapons system in all time, which Linda mentioned earlier was the F-35. Now, the F-35, by the way, has come out great. It's an incredible platform, but at the time, Congress was saying, why do the budgets keep going up? And so I remember asking him and saying, why is that? What's the challenge with this? And he said, and remember, I'm an engineer, AI person, not necessarily a hardware or a plane builder, and so I have to respect that. But I just said, why is that? And he said, you know, Tim, you're thinking about the plane as hardware that has shoots missiles and so on, and has some software modules in it and so on. He says, you're thinking about it in an older context. It really is millions of lines of code with hardware peripherals that shoot missiles and so on. In other words, what he was trying to say was, you need to pull it a bit inside out to say hardware is still, the platform is still deliverable, but the way it needs to operate, the way it's going to, quote, think or have AI or support the pilot and do all the things that now we've seen it do, that's what he was saying is the name of the game, or how to change your thinking on that. So for me, it was that kind of
Innovation begins
challenge.
with a spark, a vision brought to life in digital light.
I'm sorry, do you want to turn the...
Here, a single idea transforms into a masterpiece as intuitive gestures craft the future of flight. Across disciplines and continents, engineers unite in a seamless digital workspace. Advanced tools empower swift collaboration, each adjustment perfectly modeled, every decision informed by real-time data. In the digital realm, ideas are tested before reality. Virtual wind tunnels reveal true aerodynamic performance. Air currents dance and data flows with precision. Structural integrity is proven under simulated extremes, each challenge instantly addressed through rapid digital iteration. Optimization becomes automatic, every parameter fine-tuned by the intelligence of simulation. Manufacturing instructions are prepared digitally, guaranteeing that every part, every connection, is precisely ready for reality. Confidence builds as concept becomes certainty. Digital dreams become tangible achievement. A new era of flight ascends, engineered for excellence, delivered with speed, precision, and vision. This is the power of digital-first aerospace innovation.
So I just wanted to show you that short video because that was the storyboard I actually put together with generative AI, just so you all knew. with that. The amount of energy I put into that is incredible in terms of just being able to tell the story about a digital first. Again, digital first does not mean digital only. It just is meant to say, how do we think from an optimization context about everything that we do as engineers, as business leaders, builders, et cetera. And so one key message on this is that these are tools to facilitate the engineering, not to be the engineering. You still need the creative thinking, you still need the steering that would be required to operate on massive scale data sets and so on to be able to do that. The physics models, the fluid dynamics, the metallic properties under duress and so on that you would want to measure. You can now do that all computationally, but that's where we have to think about how we do our jobs, not necessarily by digitizing what we currently do, but to think about our inputs and our outputs and say, right, what do we want on the end, and how do we think iteratively with digital tools that can move much more quickly at speed and at scale than we've ever been able to see before. So that's like in my journey and having to think in a digital way first, like my friend at the Air Force said, that's the ask I have of the community, because I'm very excited about what's come of aviation. In my lifetime, I remember the retirement of the Concorde, and now we're here talking about, again, commercial supersonics, which is incredible. I'd like to push it because they gave me all the way to 2050, try and think about commercial hypersonics and think about pilotless aircraft. And I know some of that is not necessarily the way that we've brought up in the aviation community, but I'll just close by saying, because I wanted to make sure I had plenty of time with Linda, wanted to close and just say this moment with generative AI, but not just that, all AI, all digital, all analytics, the commodity compute that we have, the datafication that we've seen, the ability to ship data around in real time, and the way we can now collaboratively work together that we've never been able to do before, we do have to think and act differently and holistically. And I think that we can imagine the possibilities and then achieve them together, again, with digital enablement and hardware outputs to build the best and brightest things that are to come. So again, thank you all for what you all do. And I'm just going to, our main theme for our firm is so you can, and we're here to help anyone along their journey so you can succeed to do things. But with that, let me thank you and invite Linda up, who I know was going to ask me. She told me she was not going to ask me necessarily easy questions, so I'm ready wherever Linda is. Thank you very much.
Wow, that was a fabulous presentation. I loved it. From the back, I could just see your face, and I had to peek out so I could see your slides, because the pictures are really important to getting this message. I'm so impressed with your future vision. You know, my job and my role is basically solve problems of right now, and that's
like any good engineer does.
That's
right.
unique to me
Yes.
to some extent. We have lots of people looking at the future at my company. I'm just one who's focused on living to fight another day sometimes. But let's see, we have some questions for you.
Excellent.
So I know there'll be a number of them from the audience, but the first one I'm going to ask is, vertical flight is today an area of growth. Can it mature and deliver new ways to fly?
Can vertical flight do new ways? So I think yes, meaning I think if we imagine what you could do with vertical in the broadest sense possible, I do think there are newer modes. By the way, I was telling Linda, I'm the son of a Navy pilot who used to do anti-submarine warfare. I grew up in Norfolk, Virginia. And my dad was a rotary at that time. Now it's all fixed wing, what Navy does. But he flew off these small destroyers and so on. And I never imagined that I used to watch him a lot fly his Sikorsky, because you spent some time.
Yeah.
Fly his Sikorsky out to sea in pitch black in the middle of the night. And I could not have imagined like an eVTOL type environment that is, again, that future is now. So What else could we do with that in terms of transport, of lift, of any other thing, helping in construction? I think it's just a matter of where we might be limited sometimes, and like I have been on what vertical lift could mean and do. And I think it's easy to imagine the Uber or the Lyft type approach, Lyft as an LYFT, but the ride app type approach on vertical, I think, though, that's not enough. I think there's probably more that could be done.
Yeah. Well, I know you have worked for the government and the GAO, and the challenge that I see that I'd love your thoughts on really involves certification. Because
Oh, yes.
if you think about something, I'll go back to the BA 609,
Right.
several decades and not certified because it's something new and different, and the FARs don't address that new technology. How can the certifying agencies stay up and get ahead of this so that this future that we saw in your slides actually becomes reality?
Yeah, that's such a good question. The poor certification and regulatory space, because I used to oversee a lot of that also. It's tough to be a regulator or a certifier. You're always catching up with what's coming out of, the primes and the most advanced things. And usually it's like, I'm just trying to understand, how did you do this? And if you start saying, well, let's jump into all these advanced technologies, there's actually a training the certifiers or training the overseers. And that's something that I think we can't keep our eye off that ball. That has to be done because we want good rulemaking. We want good certification. We don't want it not to happen, but we want them to understand, and we understand what risks are.
Right.
Taking a risk-based approach.
Yes.
And not just taking the technology. I'm a techie, but I strongly advise against taking a tech-forward narrative into those conversations. Just say, what's on your mind? How might we do this? We're doing some things differently we want to show you, but we want to talk with you about it and make sure that we want to explain. Our burden is to explain to you what we're doing, and that's what builds trust.
Yeah, absolutely. Okay, a question from the audience. Can aviation still meet its net zero goals for 2050, and how?
Yeah, a great question. I think I wouldn't say if you're completely a purist and say absolute zero, I think that's not going to happen. I do think that you can get net close to zero, meaning I think, in my science fiction prototype, I was talking about hydrogen fuels, which again, there's folks working on this. This wasn't a thing I imagined, but there's a strong push now into that. I never thought I'd see, by the way, the electrification of vehicles sold at scale, right, that we now see with Tesla and so on, much less what we've seen in terms of the commoditization of launch. So getting back to sustainability, I think that we can learn a lot of lessons about the hybrid approaches to various things, as well as into sustainable fuels that themselves, you have to remember, if you're just saying, well, let's do biofuels, right, well, that can have a lot of carbon inputs that you really need to do a total life cycle analysis on, just so you know. All right, our king crop in the United States is corn, and that is a very fertilizer-intensive crop, and when you're saying I'm using a lot of fertilizer, I just want to say you need to think as wide aperture as possible, because you might be kidding yourself that you're being green when you're actually not in the total. That's the main.
The whole value stream
Right.
and unintended consequences
Exactly.
that may not appear.
So it's the hydrogen, I'm excited about that.
Yeah, it's super.
Yep.
Let's see. Got a lot of engineers in the room. What will change for the engineering workforce, and what role will AI play in that change?
Yeah, I think the engineers that have the ability to thrive in this environment will embrace digital as a means to an end. It's not the end itself. It's just like I remember the time when laptops came around, and school systems were just buying laptops and throwing them in the classrooms as if just by virtue of putting laptops in classrooms, just that was going to change education fundamentally as we knew it. Now, the laptop was a tool, but you had to learn how to teach to it. You had to learn how to have the student be able to learn through the mechanism. It wasn't about the laptop itself. Again, it was about the means to the end. And so that's where I see, in the same way, analogously, engineers have a very bright future by embracing these sort of approaches, thinking more holistically, but still creatively. You're still in charge. I'm not a fan, by the way, of the AI moniker, which came around in 1956 from a Dartmouth summer school. So we've been stuck with it. I think of it more as augmenting human intelligence, and I think That's the future that is bright for this, for folks that, again, at the end of the flow charts, it still gets down to hardware. You're still building something. You still got to fly something. And it was great talking with Linda in the prep room about this, because just the idea of what the tools can do for you itself is not the end all. It's still hard to put all the data together, understand your workflow, what you're trying to accomplish, how you design, et cetera. And so I think there's some adaptation, but I think that it's an exciting and bright future. And I don't think it's less engineers, I think it's more, personally. So that I swim upstream on that. This is usually viewed as the job apocalypse, but I reject that narrative, because we've seen this even as profoundly transformative as AI is, generative AI especially. It's not going to eliminate the workforce. It's just going to reshape it, and that reshaping is what we need to focus on.
Okay. This is a very popular question, so I'll ask it. What role will China play in 2050 aerospace, and can the U.S. and Europe compete?
Yeah, great question. I also, being in DC, I also sit with a lot of smart people in places like the Council on Foreign Relations and so on. So these are true China experts. And I remember asking recently a simple question: is China ascending or is China descending? Right? And I get various answers, as you might imagine, but I'm in the camp right now that I think the way that the Chairman Xi's been able to accord power to himself, his cleaning house and the regime and how it's trying to operate and really constraining innovation, I think that they're not going to be as competitive in this space as they could be. Right? I don't want to be naive on this, but I think the American advantage is always the creative risk-taking, and you have a permissionless system. For the most part, right? You still have to cross your certifiers, you still have to meet your regulators, satisfy your government customer, et cetera. But I'm just getting at overall aviation. I think that though there's still a manufacturing powerhouse in many ways, I think the level of manufacturing here obviously is growing up under the new administration, or under Trump 2.0. They're seeing massive investments. Golden Dome is just going to bid a huge bolus of money into this. And so I think we're going to have our game, but we can't sit back and be lazy. We can't sort of rest on any kind of laurels and say, we're America, it's great. We're still going to struggle with keeping our IP, right? That's the main thing. Is we can innovate here and design in Cupertino, let's say, but if it's all made in China, that's going to be a challenge. And I think we've learned that lesson. Hopefully in 2050, we will have learned that for aviation on our platforms.
Okay. Looks like my question, I have one here. Can digital engineering enable aviation to move faster and deliver better products?
That's the main idea. It's a great question. So that is the goal, is really about speed. And again, I've just mentioned in my prototype, I was talking about just the lessons we're learning from Ukraine, right? When you think about there's an asymmetric disadvantage from the defender side, as it were, and just with the things they're having to do, doing more with less. And it's using drone technology and so on. So it really is our future, just a question overall, is our future in defense aviation just, these incredibly powerful, battle-dominant machines that will last for decades on end, or can we think of more of a consumable model, cheaper, lighter, faster, et cetera? I don't think, by the way, that's an either or. I just want to share my cards. I think it's a both. I think you need to have both the battle-space dominance, right? We need the F-35 and everything coming after that. So I'm a big fan of that. I'm just also a fan of how do we think differently and learn lessons to reduce the cycle time. That's a lot of this, is getting down the ops tempo, bringing certainty to the certifiers, bringing certainty to your quality assurance, your quality engineer, bringing a certainty to your C-suite, your investors. All of those sort of things are what I see as digital engineering enabling that fundamentally. So that's why I'm excited about it, if we could get it right.
Excellent, excellent. Any other comment you want to make to the audience?
So I think that this is, again, there's a category of historians called scientific or technology historians. And they'll go through history and tell you about this is where this happened and here's how the world changed. And we even do this in history. We talk about things from we have a material science perspective. We say we were in the Iron Age, the Stone Age, et cetera, right? So we even appeal to technology. And so I think that's exciting because as you go into, I was born in the 20th century, and I think the 20th century was defined by two key technologies, nuclear, and then really the transistor, which went into the internet. But arguably you could say a lot of flight as well, so there's really multiple in that. But the point from a history perspective is the compressed timescale of what we're seeing in innovation. It used to be take centuries or millennia or something for something to change, and now we're talking about a compressed timescale where we're just seeing things back to back to back. And what's going to continue to happen is AI and Gen AI is going to be underpinning all of those particular innovations. They're running an experiment right now, for example, Linda, where they're asking, pretend Einstein didn't exist. If we fed these advanced reasoning models that are coming out of Gen AI, all of the papers back in the late 19th or now early 20th century, Einstein, could we have come up with E equals mc squared, right? That's a big, interesting, new Turing test, I'll call it, right? And we don't know yet, but I'm saying that's an interesting question about what these tools can bring in terms of deriving, not just repeating new knowledge in a way that makes stuff up, and trust is a big thing, as we know. It's about how do we get new and net knowledge, and how does that inform all of our jobs, especially and including aerospace engineering. So I think that we're seeing from a long-term perspective of horizon, we are in one of the most transformative technological revolutions of our lifetime, hands down. So the question is, how do we leverage that? We are going to figure out, humans always find out a way to derive new value. And we will continue to do that with this technology as an aerospace engineer, as a business leader like yourself. The question is, how I use this, using design thinking, attacking my job from a task perspective. What is it that I do that I might be able to offload to a machine and allow me to do more of the heavier thinking, strategic stuff that should be and only be rest with the human. So that's a way of saying we're in a very transformative time. Embrace this. It's not your enemy, but you have to give it grace as well. It's not a perfect technology on this. You're not going to push an easy button and an airplane's just going to come out the other end. It's going to have to be a lot of things in there, but thinking from an integrated perspective, thinking holistically, thinking digital, agile is the way forward on that, and I'm very excited about it.
Well, Tim, I just want to thank you. I think it's been a fascinating opening. Let's give Tim another round of applause, and from the aviation.
Thank you very much.
I want to present
thank you.
AIAA
I love this.
Courant.
This is great. Thank you so much. Appreciate it.
Great to meet you.
Nice to meet you as well.